Have you ever gazed at the night sky and pondered what's beyond the sparkling stars and the immense stretch of space? It turns out our universe might hold more than what's apparent to our eyes. In recent times, researchers and thinkers alike have been delving into the astonishing concept of higher dimensions, the notion that realms beyond our familiar three-dimensional world exist. Picture a two-dimensional creature living on a flat plane, suddenly encountering a three-dimensional object like a sphere or a cube. For them, it would seem like magic, shattering all the norms of their existence. Now imagine us inhabiting the three-dimensional world, trying to comprehend the reality of a fourth, fifth, or even a 10th dimension. It's a thought that pushes the boundaries of our imagination. But what if grasping higher dimensions could reveal the universe's secrets? In this presentation, we're going to embark on an intriguing trip through the realm of higher dimensions. We will look at how experts in mathematics and physics have wrestled with this bewildering idea and how it might potentially make sense of some of the largest enigmas in science, from the intricacies of quantum entanglement to the essence of gravity. But be prepared. Once you delve into higher dimensions, there's no turning back. Your view of reality might be altered forever. So strap in and prepare to have your mind stretched in ways you never imagined possible. You see, the concept of higher dimensions isn't merely a complex theoretical notion. It has tangible implications that could drastically change how we comprehend the cosmos. It all begins with a straightforward question: what exactly is a dimension? Explaining dimensions, picture a universe where everything is flat, similar to a sketch on a piece of paper. That's a two-dimensional world, a place where objects only possess length and breadth with no depth. It's an idea that's straightforward to grasp, but things get intriguing when we introduce another dimension. Suddenly, we step into the world of three dimensions, where objects have length, breadth, and depth, the reality we live in and experience daily. But here is where it gets captivating. Just as a two-dimensional being would struggle to visualize a three-dimensional object, we too might find it tough to perceive higher dimensions. Mathematicians have always been drawn to the idea of higher dimensions. They've figured out that each subsequent dimension is perpendicular to the last one, so the fourth dimension would be at a right angle to our three-dimensional universe. It's a challenging idea, but one that reveals a multitude of possibilities. Now you might wonder, how can we begin to imagine these higher dimensions? Well, get ready, because we're about to dive into some of the most intriguing thought experiments in the annals of science. Envision a two-dimensional being encountering a three-dimensional object slicing through their plane. To them, it would look like the object was magically transforming, defying all the principles of their known reality. Now apply this analogy to us, beings in three dimensions attempting to understand a four-dimensional hypercube or tesseract passing through our space. It would seem like something straight out of a science fiction story. The intriguing part is, even though we can't directly witness these higher dimensions, we can investigate them through mathematics. And what we found is truly astounding. Take string theory, for example. It's one of the leading frameworks for a unified theory of everything, suggesting that the universe is composed of minuscule, vibrating strands of energy. These strings are conceived to exist in up to 11 dimensions. Yes, 11 dimensions, each folded so diminutively that they evade our observation. Yet they are present, shaping the very fabric of reality. But it doesn't end with just string theory's revelations. The concept of higher dimensions has profound implications and might hold the answers to some of the greatest riddles in physics, offering explanations for quantum entanglement to the nature of gravity. This is only the beginning. Let's delve into the role higher dimensions play in physics. Have you encountered this concept of quantum entanglement? It's a strange quirk where two particles become instantly connected regardless of their distance apart in space, what Einstein called spooky action at a distance. This has puzzled experts for quite some time. However, some theories propose that such quantum entanglement could be accounted for by particles being connected through higher dimensional space, much like 2 points of a wormhole. Although it's a head-spinning thought, it illustrates just one of the countless ways higher dimensions could revolutionize physics. Now consider gravity. Our current grasp of gravity, based on Einstein's theory of general relativity, functions well on a macro scale. Unfortunately, it falters on the smallest scales. Enter string theory. By asserting that the universe's fundamental elements are tiny vibrating strings within higher dimensions, string theory could unify gravity with other fundamental forces, crafting a more cohesive understanding of the forces that rule our universe. But higher dimensions fascinate not only physicists and mathematicians, they've also stirred the imaginations of philosophers, mystics, and artists throughout the ages. From spiritual traditions to the masterpieces of Salvador Dali, the concept of dimensions beyond our own has encouraged countless individuals to ponder the essence of existence. Now let's touch on the philosophical and spiritual implications. The thought of dimensions beyond our own has spurred philosophers and spiritual seekers for ages. For many, this notion of dimensions beyond the tangible is akin to a metaphor for the mysteries of consciousness and reality. In Jewish mysticism, known as Kabbalah, there's a belief in the Sephirot, emanations of God represented as extending through various dimensions. Each Sephirot symbolizes different aspects of God's creation, from wisdom to beauty. Through study and meditation on these emanations, Kabbalah practitioners aim to glean a deeper insight into the divine. In Hinduism and Buddhism, the concept of multiple dimensions or lokas exists, each with unique inhabitants and governed by different physical laws. Access to these lokas is sometimes claimed to be possible through meditation or spiritual practices, inviting experiences beyond the physical realm. This notion of transcending physical reality to explore mental frontiers is a recurring theme across several spiritual traditions, from shamanic journeys to psychedelic experiences in specific cultures. Humans have long sought to breach the confines of the material world. More recently, these concepts have gained traction in the New Age movement, which often combines scientific and spiritual notions. Some New Age thinkers suggest that by tapping into higher dimensions, we can connect with a universal energy field that infuses all of reality, influencing our ability to manifest desires and shape reality. While these ideas may verge on pseudoscience for some, they reflect our enduring urge to make sense of the universe and find our place within it. Whether through scientific exploration or spiritual pursuit, reaching for an understanding of higher dimensions is, at its heart, a quest for meaning and purpose in an expansive and intricate cosmos. Our forays into the enigma of higher dimensions may be driven by spiritual or philosophical curiosity, yet the foundation of our understanding remains solidly within the scientific domain. Some of the most groundbreaking work in physics and mathematics today is heading towards uncovering the secrets of higher dimensional space. Let's delve into the current studies and what the future might hold in this arena. Recently, the pursuit of higher dimensions has become a hotbed in the theoretical physics community. Concepts like string theory and M theory suggest that our known cosmos could be just one among numerous universes, each nestled within its own higher dimensional bulk space. One particularly gripping line of inquiry is taking place at the Large Hadron Collider, LHC, in Switzerland. This gigantic particle collider is crafted to catapult protons at each other at colossal speeds, simulating conditions shortly after the Big Bang. Scientists scrutinize the remnants of these collisions, hoping to discover hints of particles that would be indicative of higher dimensional spaces. Even though the LHC has yet to uncover conclusive evidence of extra dimensions, the quest continues. There's a belief among some scientists that the breakthroughs in higher dimensions might not be far off and that they could redefine our understanding of all creation. Another promising application for higher dimensions lies in the investigation into dark matter and dark energy, the elusive entities believed to make up most of the universe's mass and energy that have so far dodged direct detection. Some hypotheses posit that dark matter and dark energy might be better explained by the existence of higher dimensions. And as we probe these enigmatic substances, we could unlock new perspectives about the fabric of reality. Yet, even more exciting is the potential that higher dimensions hold for future tech and applications. Take quantum computing, where the concept of higher dimensional quantum bits or qubits could be deployed for computations far surpassing the capacities of traditional computers. With such advanced technology, we could tackle an array of complex issues, from medication discovery to improvement of materials science, and even enhance artificial intelligence. Moreover, there's talk about the potential creation of new types of materials boasting extraordinary traits. Theoretical musings propose that by tweaking the geometry of higher dimensional space, we could engineer materials with negative indices of refraction, leading to technologies like invisibility cloaks or ultra-efficient solar cells. Beyond even these groundbreaking ideas, we venture into far more speculative territory. This includes notions of utilizing wormholes for space-time travel or the creation of customized pocket universes, each with their own distinct physics. While these concepts remain within the realm of speculation and science fiction, they provide a window into the immense progress we've made in comprehending higher dimensions. As we continue to break new ground in our understanding, it's plausible that the concept of higher dimensions will be instrumental in shaping the trajectory of scientific discovery and innovation. Whether we're unraveling the universe's mysteries or constructing new tools and technologies to solve our most complicated challenges, the study of higher dimensions promises a transformative impact on our collective future. In anticipation of what's to come, it's clear that higher dimensions represent a key frontier in our ongoing quest for knowledge. However remarkable the journey to higher dimensional understanding might be, it's important to remember that the journey often holds as much significance as the eventual destination. As we look ahead, the significance of higher dimensions to the future of science and technology cannot be overstated. While embarking on this intellectual voyage, we recognize that the notion of multiple dimensions will play a critical role. The exploration of higher dimensions isn't just a theoretical exercise, it has practical implications that could revolutionize our understanding of the universe and enhance the way we interact with the world. To summarize, our exploration into higher dimensions stretches beyond the confines of abstract thought and into the realm where science meets imagination. While the tangible applications of this research might not be immediately clear, the potential for breakthroughs in physics, technology, and even our comprehension of reality is boundless. The investigation into higher dimensions represents one of the most thrilling frontiers in modern science. Ultimately, the uncharted territories of higher dimensions lure us with promises of novel theories and technologies. Yet, as we stand on the brink of these discoveries, It is science that grounds us and guides our search for truth. The pursuit of knowledge within the multidimensional space, a space that may hold the secrets to some of the universe's most profound questions, is a testament to human curiosity and ingenuity. In our journey to uncover the mysteries of higher dimensions, we are reminded that the quest for knowledge is without end. Each new insight leads to more questions. Each discovery propels us further into the abyss of the unknown. But this is the essence of scientific adventure. The relentless desire to understand, to question, and to dream of possibilities once thought impossible. As we look toward the future with its untold potential and inevitable challenges, we are emboldened by the knowledge that our foray into higher dimensions is more than just an academic pursuit. It is a path to new frontiers in every sense of the word. To comprehend higher dimensions is to reimagine our place in the cosmos and to reevaluate what it means to exist in this vast and ever-expanding universe. And so, our voyage continues, driven by the timeless and unyielding spirit of human discovery toward a horizon that is forever receding, forever beckoning, and forever filled with wonder.